A rock thrown vertically upward from the surface of the moon reaches a height of s equal to 24t minus 0.8 t squared meters in t seconds. Find the velocity of rock at any time t. So we all know that the velocity is the first derivative of the particle's position with respect to time. So meaning we just have to get the derivative of our function with respect to time, which is the function is 24t minus 0.8 t squared. So what's the first derivative? So this will be 24 minus 1.6 t, and that's meters per second. A car engine accelerates from its stationary position for 8 seconds and travel at a distance of 280 meters. According to the mean value theorem, the speedometer at a certain time during the acceleration must read exactly what? So, using our kinematic equation, we all know that S is equal to VOT plus 1/2 AT squared. Since it started from the stationary position, so our VO, or the initial velocity, is 0. So S, what's the displacement covered here? So that is 280 meters is equal to 1/2 A, and our time is 8 seconds, and that will be squared. So the value of our acceleration will be 8.75 meters per second squared. And then we want to find our final velocity after that acceleration. So we all know that the final velocity squared is equal to initial velocity squared plus 2 AS. So again, initial velocity is 0. So final squared is equal to 2. Acceleration is 8.75 and S is 8. Final velocity will be again, S here is 280. Final will be 70, and that's kilometer per hour. And we want to find the velocity here according to the mean value theorem. So to find that velocity mean, so that will be our initial plus final over 2. Initial is 0, final is 70, and that is divided by 2, and that is 35. So correction, so this is meters per second. So this is meters per second, and to make it kilometer per hour, multiply it by 3.6. So the answer is 126 kilometer per hour. At the minimum point of y is equal to f of x, the curve is concave upward. Compute the maximum area of a rectangle whose base is on the x-axis and whose upper 2 vertices lies on the parabola. So for example, I have here a rectangle and base lies on our x-axis. And then there is a parabola bounding this rectangle. So let's say this is x, and since it is a rectangle, it is symmetrical also on the other side. And let's say the height is y. So to find the area, so that would be base times height. Base is twice of x, and height is y. And we all know that y is equal to 12 minus x squared. So to simplify this, so this will be 24x minus 2x cubed. So that will be our equation of area. And let's get the derivative of both sides with respect to x. So this will be 24 minus 8x squared. 6x squared rather. And then for our maximum minima, first derivative must be equal to 0. So 6x squared is equal to 24. Dividing both sides by 6, so x squared will be 4. And x will be plus or minus 2. So let's say we use the positive value first here. So to have our positive value, let's solve for our area. Area here will be 24 times 2 minus 2 times 2 cubed. So what is our answer here? So answer is 32. At the point where y prime equals 0 and y changes from positive to negative as x increases, y is maximum. The area in the first quadrant bounded by the, so we have here x squared equals 8y. That is a parabola opening upward with vertex at 0, 0. The line x equals 4, when variable is only x, that is a vertical line at x equals 4. And the x-axis. What is the volume generated by revolving this area about the y-axis? So let's say we pick a vertical element. So this will be L, D, X. So as you can see, my element here is parallel to my axis of revolution. So we will be using the shell method. So volume will be 2 pi integral of R, L, D, X. So what's the radius here? That's the distance of our element to our axis of revolution. So this is X. And L is y up minus y down. Y up, that is our parabola. So that's x squared is equal to 8y. So y is equal to x squared over 8. And y down is our x-axis, and the equation there is equal to 0. And our limit will be from the origin to x equals 4. So volume will be 2 pi integral. R is our x. L is y up minus y down. And limit will be from 0 to 4. Volume will be 50.26 cubic units. Calculus was invented by D. Catenary is in the shape assumed by a perfectly flexible, uniform cable hanging between two supports. It is a graph of hyperbolic cosine. A bicycle travels along a straight road at t o'clock. It is t squared miles from the end of the road. Compute its instantaneous velocity at 3 o'clock. So instantaneous velocity is the first derivative. So what's the first derivative of t squared? That would be 2t. And we want to find the velocity at 3 o'clock, so t equals 3. So instantaneous velocity is 6 miles per hour. How much work is required to pump all of the water from a right circular tank? That is 8 feet in diameter. And 9 feet tall. That's our height. If it is emptied at a point of 1 foot above the top of the tank. A formula in pumping our liquid in our container will be gamma QH. Gamma will be the specific weight. So this is water, so this is 62.4 pounds per cubic foot. Q here is the volume. So the volume of cylinder will be the area of the base, which is the circle, pi over 4 d squared times height. So cancel all of our feet. And h here will be the distance to our location to where we want to carry our water from the centroid of our container. In terms of a cylinder, it is located exactly at the center. So from the center to the top, this is half of 9 feet. So that will be 9 over 2. And we want to carry the water at a point 1 feet above the top of the tank. So that is another 1 feet. So H will be 1 plus 9 over 2. So answer here will be input pound 155,260.